we're going to look at function notation and then also just how to evaluate functions. So we just got done going through and checking to see if something's a function or not. When you have a function, it can be represented different ways. So it could be represented by a set of points, which we saw lots of those in the last lesson, or by a graph. We saw those also. But you can also represent it with an equation. So a lot of us, as we learn how to work with functions, a lot of us use y. So you'll see this quite a bit. Well, they write the equation of a function like that, y equals 2x plus 3. And we could take different numbers and plug that in there. For example, we could say, when x is 1, what would I get? So I'd go y equals, plug 1 in for x, and just figure out what y comes out to. So y would equal 2 times 1 is 2, 2 plus 3 is 5, so y is equal to 5. Well, function notation is just a way of writing a function, and what it does is instead of putting y equals, we do what's called f of x. So it looks like this. So the f is just the name of the function. And it actually doesn't have to be f. A lot of times you'll see a g of x or an h of x, or it really could be any letter, but the f just represents the name of the function. The x in the parentheses represents what you're plugging in. So it's what you're plugging into the function. So here's an example. If right there we just plugged 1 into the function. If I wanted to plug what, this is the exact same function. So right, f of x and y mean the same thing. So if I take 1 and plug it in, it looks like this. I'm going to go f of 1 equals, just like we did before, 2 times 1 plus 3. So now I have f of 1 equals 2 times 1 is 2, 2 plus 3 is 5. So we got the same thing because it's the same function. Now, the reason why we use function notation, really the advantage to it is, if I look at this answer over here at y equals 5, I know what y came out to, but it doesn't really tell me what I plugged in. Now we can look back up here and say, hey, I plugged in 1, right? 1 is what I plugged into the function. With function notation, though, it includes all the details, right? I plugged 1 in, right? I plugged 1 in to f. F is a function, and I got 5 back out. So function notation is all about, it's really focused on, what did I plug in? 1. What did I plug it into? The function f. And what did I get back out? 5. Couple key things. We have to be careful. This does not mean f times 1, right? F of x, and by the way, the way you say this, if you want to write this down, sorry about that. If you want to write this down, f of x means like that. And what it really means is x is what you're plugging into the function. So let me show you another example here. If I have this, if I have g of x equals 4x plus 1, and I want to find g of 3. Okay, all that means, I go g of 3, and I want you to write that down. Make sure you write down the g of 3. So g of 3 is equal to, and all that means is over here on the right side is I'm plugging 3 in for x and working that out. So g of 3 is equal to, never do anything with the left side, I'm just working out the right side. 4 times 3 is 12, 12 plus 1 is 13. And there's my answer. So g of 3 is equal to 13. Let's try another one. This is an absolute value function. So I have f of n. Notice in this case it's using n instead of x, but it's the same thing. I'm just going to go f of 1 is equal to 1 plus 2 plus 2. Again, never do anything with the left side. F of 1 equals, this stays the same. And let's see, 1 plus 2 is 3. So I'm going to keep simplifying. So f of 1, absolute value of 3 is 3. 3 plus 2 is 5. So f of 1 is equal to 5. And again, all that means is I plugged 1 into my function f, and I got 5 back out. By the way, you could actually write this as a coordinate point. If you wanted to, I plugged 1 in, and I got 5 back out. So that would be, if I wanted to graph that solution, I could actually graph that point 1, 5, and that would represent plugging 1 in and getting 5 back out. Let's do this one. This is a quadratic. Notice how the highest power is 2. We've talked about that. So we call this a quadratic function. So I'm going to go k of 10 Never do anything with the left side. Just plug it in the right side and work it out. So k of 10 equals 10 squared is 100. 100 minus 5 is 95. And I'm done. Right, I plug 10 into my function. I got 95 back out. Now, when it could be a little bit different, well, let's do this problem actually first before I jump into that next one. So it says, right, f of x equals x squared minus 5x. It says find the range of the given function for the domain. So what that means, right, this is the domain. So these are my x values. Talked about that yesterday. Domain is the x value. So I want to plug those in and find the y values. So what it really means is just to do each of these. I want to go f of negative 2 and plug it into my function. So I would get negative 2 squared minus 5 times negative 2. And now you choose. You can work that out by hand. You can even use a calculator if you want, but we want to find out what that comes out to. So negative 2 squared is 4. If I have a minus 5 times a negative 2, that changes the sign. There's two negatives there. So f of negative 2 comes out to be 14. Then it wants me to do f of negative 1. Do the exact same thing. You just plug a negative 1 in. So I get negative 1 squared minus 5 times negative 1. So f of negative 1 equals, that's 1. Minus 5 times a minus 1 makes it a plus 5. So end up with 1 plus 5. So it comes out to be 6. Let's do 0. F of 0 is equal to, well, that's a pretty easy one because 0 squared minus 5 times 0. So f of 0 comes out to be 0. And you would just keep going. We'd also plug in the 4. Let's do the last one. F of 4 is equal to, and I go 4 squared. I don't need the parentheses now because it's positive. You can put the parentheses if you want. So f of 4 is equal to 16 minus 20. That's what, negative 4? So find the range. Well, here would be my range then. These are all my range values for that domain. I would have, let's see, I got 14, I got 6, 0, and negative 4. So that would be the range that fits with that domain. When I plugged in those x values into my function, those are the y values I got back out. The ones that are a little bit different is something like this. So it says evaluate each function. It tells me g of n equals n plus 4. It says find g of a squared. So now I'm not plugging in a number, I'm plugging in a variable. So I'm plugging in that a squared. So it's exactly the same thing though. I'm saying like that, g of a squared is equal to, and we're just going to plug a squared everywhere there's an n. So it'd be a squared plus 4. I just take that a squared and I replace the n with the a squared. If you can simplify it, we should. A squared plus 4, I can't add those or I can't simplify it. So that's my answer. That's all I'm doing. That's my new, that's what g of a squared equals, just equals a squared plus 4. This one is wx equals 4x. So this time, I'm going to plug in x plus 4. So everywhere there's an x, I have to replace it with an x plus 4. So it's going to be w of x plus 4 is equal to 4 times, and in place of that x, put in the x plus 4. Put it in parentheses because the 4 is multiplied by the x. So if I'm replacing the x with x plus 4, the 4 has to be multiplied by that whole thing by the x plus 4. This one we can simplify. So we can never do anything with the left side. Just work out that right side. Distribute that 4. That'd be 4x plus 16. That's really all we can do. That's my answer. W of x plus 4 equals 4x plus 16. Let's do this last problem. This one a little more complicated. I have h of a equals 2a minus 5, and I want to find h of 4 plus a. So again, I'm going to come down here. I'm going to do h of 4 plus a. So everywhere there's an a on this side, I have to replace it with an a plus 4. So it's going to be 2 times. In place of that a, I'm going to put in the 4 plus a. And I still have the minus 5. Okay, that's my answer. Let's just simplify it a little bit, though. This one we can definitely simplify. If I distribute the 2 through, that would be 8 plus 2a minus 5. And I actually have over there some like terms. The 8 and the minus 5 I can combine, so it would be 2a and 8 minus 5 is a positive 3. And I'm done. Remember, never do anything with the left side. That's just telling me I plugged in 4 plus a into h, and I got back out 2a plus 3. That's my answer. Okay, so that's a little bit, that's function notation and evaluating functions. And I have some practice there where you can go through and do some of these and make sure that we understand it. Let me know if you have questions.